Hello and welcome back for another VMK in the game development series. This VMK is going to wrap up the mini-series on using textures in our game engine. In the first VMK in the texture mini-series, we created the noTexture class. This class enabled us to load a TGA file from the hard drive into memory. In the second VMK, we implemented the noTexture class into the scene class so that we can load in textures into our game engine. In this VMK, I'm going to show you how to modify our existing objects, these objects being the FlatGrid, the house, and the triangle, so that we can add textures to them. So let's get started. As you remember, last thing we did is we went into the scene update function, and I showed you how we're going to be changing our renderer for each of the objects that we currently have in our game engine. We're going to be using the select texture ID or the select texture functions to select the specific texture that we want to use that should have already been loaded up and initialized. Before I go in and modify the render functions inside each of these objects, I want to talk a little bit about how textures work in OpenGL. Okay, let's take a look at this figure here. A texture in OpenGL is represented by the following coordinates. The bottom left-hand corner is 0, 0, and the top right-hand corner is 1, 1. So when representing a square, you would use the full range of texture coordinates from 0, 0 up to 1, 1, as shown here in this diagram. When I show the texture inside the square object, we can see it would look something like this. When working with textures, we don't talk about the x and y coordinate systems. Instead, we talk about the s and t coordinate systems. I've labeled them here to show you which axis is the s-axis and which is the t. The s-axis acts as if it's the x-coordinate. The t-axis is equivalent to the y-axis in a regular coordinate system. To avoid confusion, instead of using x and y, we use s and t to represent textures. Now let's take a look at what happens if we apply this texture onto a triangle. Let's say we had the following triangle in our scene. The triangle itself is going to be comprised of 3 vertices. The values of the vertices could be anything. I just specified them here in red. For each vertex, you need to specify a texture coordinate, and I've arbitrarily chosen the following values. 0, 1 for this one, 0, 0 for this one, and 1, 0 for this one. If we were to apply this texture onto this triangle, we would see the following. Notice that the texture is sort of stretched and skewed. The way that OpenGL handles this texture is it's going to take all the values inside this lower triangle and map them onto our triangle that we have here. It's important to understand how this works so that when you're building your textures or your objects, the texture is applied correctly. Let's take a look at another example. Let's say that we're working with the following triangle. The vertex values for this triangle could be anything, so I'm going to show them here in purple. I've assigned the following values as the texture coordinates for each of the vertices. This one's 0, 1, this one's 1, 1, and this one's 0.5, 0. What do you think will happen when we apply a texture to this object? If you guess that the texture itself is going to be cut out of the middle, like so, then you've guessed correctly. So in other words, when applying a texture to an object, what we're doing is we're taking the values from this square object and taking a portion of it to map onto our real object. When working with textures, what we do is we take the texture coordinate values to specify a region on the texture. This region is mapped directly onto the object that we're trying to texture. It is important to notice that the values of the texture coordinates always go from 0 to 1. If you specify values beyond 1, then the texture mapping has to be defined within OpenGL. We can choose to either clamp textures, we can choose to repeat them. If we choose to repeat the texture, then if we had a texture coordinate value of 1.5, that would be equivalent to a texture coordinate of 0.5. The texture itself would just continue wrapping around. We'll see this in action in a minute when we work with the FlatGrid class. Okay, let's go back into our code now. All texture coordinates are going to be represented by 2 values. So I'm going to create a new class and I'm going to call it vertex2 to contain these 2 values for each texture coordinate. Let's go into our Solution Explorer under our Object Library and select add new item. We're going to add a CPP file and call it vertex 2. And we're going to repeat that for the .h file as well. Let's start with the .h file. Our vertex 2 class is going to look very similar to our vertex 3 class. The only difference being is the vertex 3 class will have 3 coordinates, whereas vertex 2 will only have 2 coordinates. Our class itself has 2 constructors, a null constructor, and a constructor that takes in 2 values. X is going to represent our S coordinate, and Y is going to represent our T coordinate when working with texture coordinates. We have 2 members, our X value and our Y value. Inside vertex2.cpp, here's the implementation. At the top, we include our vertex2.h file, and then we have our default constructor. The null constructor is going to set our X value and our Y value equal to 0. Our other constructor, which takes in an X and a Y value, is just going to set the member variables for the X and the Y appropriately. Our destructor doesn't do anything, so it's blank. Let's save this and see if we can compile our code. Okay, that looks fine. Now that we have this vertex 2 class, we can start modifying our object classes. Let's start by adding textures to the triangle class. Open up triangle.h, and we'll scroll down to the member variables. Since we have 3 vertices in the triangle, we're going to need 3 texture coordinates. So I'm specifying them here as MT1, MT2, and MT3. I'll label this as vertex coordinates. Since we're using vertex 2 here, we need to make sure we go to the top and include vertex 2. Now inside the constructor of the triangle, we need to initialize those values. I'm going to initialize them in the same way that I showed you in the image before. The first texture coordinate is going to have a value of 0, 1. The second texture coordinate is going to be 0, 0, and the third texture coordinate is going to be 1, 0. You can choose any values here that you wish. The other thing we need to change is our render function. Now remember, in our scene, we're going to be passing in a Boolean value into our render function. So our render function must accept a Boolean parameter. Let's go back into the triangle.h here and modify the render function. If the value here is true, then we're going to render with the texture. If it's false, we're going to just render the same way we're rendering it right now. To make the changes inside the render function, we're going to do the following. If texture is true, then we're going to render the triangle with the textures, which is shown here. Otherwise, we're going to render it the exact same way we did before. Now let's take a look at this code here. For the first vertex that we go and render on the triangle, we need to specify the texture coordinate. We can do this by using GL texture coordinate 2f, and we pass in our mt1.x value and the y value. We then specify the value for the first vertex coordinate. Then we do the same thing for the second vertex coordinate, and then for the third vertex coordinate. OpenGL will handle the mapping that's required to stretch or compress the texture to make it fit onto the triangle surface. Let's save this and try to render it and see what happens. We can go back here and let's change the update function. I'm going to specify to draw the ground, and I'm going to delete this for now since we haven't updated the render yet. I'm going to render the houses, and I'm going to render the triangle, which is currently our window, and I'm going to specify here false, just so that we can see what it looks like initially. Okay, our scene is very dark, which makes me believe that our lights are turned off. Let's take a look at what kind of light sources we're using. Okay, we specified to use a spotlight. Let's change this to be a regular point light. and see what that looks like. That's a little bit better. The scene is still pretty dark though. Okay, I suspect that there's an error inside the node texture. Let's take a look in there. Yes, here we are enabling textures, but at the very end we forgot to disable the textures. So I went ahead and I added disable textures at the very bottom of the create texture OpenGL. Now when we go and compile our code and run it, the scene actually looks correct. What was happening before is the scene was expecting us to use a texture because we've enabled textures, but we haven't selected which texture we want to use. So that's why everything was kind of the wrong color and dark. Okay, so this is what the scene looks like without any textures. Now let's go render this scene with the textures turned on for the triangle. We'll go back down to the update. Now let's replace this with the following. So we're going to select to use the colorTest.tga texture on our triangle. We see that the image is textured on the triangle, but the rest of the image has turned black again. Let's go and correct this. Again, we're running into the same problem because inside our scene, we're enabling our textures here, but then we never disable them for the next time we go through. We can go into our code and specify we're going to disable textures, or we can do the following. If we specify select texture ID 0 right after we render our triangle, this will disable our textures. Let's take a closer look at what select texture ID does. You'll notice the program will go into here, and then as soon as the ID number is equal to 0, it's going to go and disable the textures. I noticed also that inside select texture, we're missing our disable at the top here, so we need to go and add it in. Down below, we implemented the disable if we cannot find a texture name. But if the value for the texture name here is invalid, we also need to disable our textures. Be sure to add this correction into select texture for our scene. Now let's go build our program and see what the scene looks like. Okay, now we finally have our triangle being rendered with the textures, and the rest of the scene seems to be okay. When I'm looking at the colors on the texture, they don't quite seem correct. If we go back and take a look at our color test image inside PaintShop Pro, you'll remember that our colors were red, green, blue, cyan, magenta, yellow, white and black, and then a rainbow. However, when we're rendering, we don't see red, green, blue, cyan, magenta, yellow, and so on. Instead, we see the following. We see red, green, black, green, red, yellow, black, and then a rainbow. Why is that? Well, the explanation is actually quite simple. Let's take a look at how we initialized our scene. Inside the initialization, we give all of our objects colors. And the color we gave for our triangle happened to be here. Our triangle is actually a yellow color. When the base color of the triangle is yellow, and the texture itself has its own colors. When they get blended together, you get those weird colors on the screen. If you actually want the triangle to look exactly like the texture, you need to make sure you render your objects in white, because then when we do blending, the blended colors with white actually turn out correct. Let's change our triangle base color to be white now to see if that corrects the problem. And it does. Notice now that our texture which is applied to our triangle, is the right color. We have red, green, blue, cyan, magenta, yellow, white and black with some grays, and then the faded rainbow colors. Notice that the alpha channel for the faded is working correctly because we can see through that part. The solid colors located in front of me now, we can't see through because the alpha channel was opaque. So that's how we apply textures onto our triangle class. Let's go and also modify textures for the flat grid as well as for our houses. We might as well get rid of this code down here since we're not going to be using it anymore. I'll just select this and delete it to make some room for the rest of our code. Once we change the render function for these other objects, we won't need to call selectTextureID 0 since we'll be calling selectTexture inside each of the render calls. This was just a little hack that we had to do to render the textures correctly for the one triangle. Oh, I guess I can go and demonstrate selectTextureID. Actually, let me put that selectTextureID back, and I want to show you that if I go selectTextureID and select 1, the correct texture is actually rendered on the triangle. Remember I was telling you before, we can use either method. We can either use the ID numbers or the name of the texture. Both functions do exactly the same thing, either selectTextureID or selectTexture. Now let's go and modify the FlatGrid class to enable us to texture that as well. We first need to open up the FlatGrid.h file and make some modifications in here. We're going to need to include our vector2 class, so I'll add that to the top. We'll need to add some members to contain all of our texture coordinates. So I'm going to do that right here. I'm going to call the texture coordinates m_t and the vertex coordinates remain m_v. Notice that we're specifying a pointer here for the texture coordinates. We need to do this because the number of vertices for our flat grid is going to vary, which means that we're going to have a variable number of texture coordinates. Let's save this and go and modify the flatgrid.cpp file now. Looking back at the constructor here, we call the new operator to specify how much memory we need for all the vertices. This is going to remain the same, but we need to also add in a new operator for the texture coordinates. So we have the same thing here for the vertex coordinates, but now I've added another new call for the texture coordinates. If both of these are valid, then we continue on through. Otherwise, we call safe_delete for the vertex coordinates and safe_delete for the texture coordinates to clean up any memory we may have allocated. If everything went successfully, we go through our double for loop and we calculate the vertex values for the vertices, same as we did before, but this time we go and assign values for the texture coordinates as well. The x value for each texture coordinate is going to be equal to the x value generated from this for loop, and the y value for each texture coordinate is going to be equal to the total number of divisions in the z-axis minus the current z value. So in other words, our flat grid is a giant rectangle. We're going to make the bottom left-hand corner equal to 0, 0, and the top right-hand corner equal to the number of divisions in x, comma, the number of divisions in z. You'll notice that the texture coordinates are no longer values between 0 and 1. They could be if the number of divisions in x and y are set to 1. However, most likely they're not going to be. This means that our texture coordinates will need to wrap to fully texture the entire flat grid. If they don't wrap, then you'll get some weird behavior on the screen. And I'll be showing you this in a minute. Let's save that. We need to make one more modification into the destructor here. Since we're allocating memory for the texture coordinates, we need to make sure we deallocate the memory inside the destructor, as shown here. We can also replace this old method for deleting the vertices with safe_delete array, same as we did here up above. Lastly, we need to go and update the render function. So going back into the flatgrid.h file, We need to go and add our Boolean value into the render, and we need to do the same thing inside our CPP file. I'm going to replace this existing code with the following. We're still going to set the color for our flat grid, and we're going to set the normal to be pointing upward. But now, if the textures are turned on, we go through our double for loop, assigning the texture coordinate values as well as the vertex values. The texture coordinate values were initialized inside the constructor. If we don't wish to use a texture, then we'll just go and render the object the same way we did before. Let's save this and run it to see what happens. We can go back here and specify which texture we wish to use. I'm going to select to use the same color test texture that we've been using so far. We'll also need to move this select texture ID to be located underneath this render call. Okay. Notice now that the flat grid is rendering with a texture, but the colors are off again. The colors are off for the same reason that we had the problem with the triangle class. We need to make sure we select a white base color for the flat grid, or else the textures won't be rendered properly on top of that flat grid. So we need to go into the initialization function inside the scene and specify we want to make the ground white. Now let's take a look at our object. Okay, now we see the texture being rendered on top of the flat grid. Notice that it's repeating over top of the entire surface of the flat grid. If we didn't want the texture image to be repeating, we can go into our node texture class and change the behavior of the texture. Remember here, we had our wrapping method for the textures. We've set them both to be repeating in the S and T direction. Let's change it so that we're going to clamp it in the S direction and see what that does. Notice that the texture is repeating in the Y direction, or for us it's in the Z direction, but in the X direction, which is this way, it's just clamped. So the values just continue going straight across. If we change this to be clamp in both directions, you'll notice that the texture only appears in the bottom left-hand corner, which is back here. Everything beyond that is just clamped to the values that are at the edges. Let's change this back to be repeating. I've made a new texture to apply to the ground so that it looks a little bit more realistic than using our color test TGA file. Let me show you what that looks like. Here you see there's a clover image. Now this image is actually kind of special because it wraps in both directions, the X and the Y directions. If we're to lay this down over top of our flat grid, you'll notice that it's seamless. You won't be able to see the edges of the image. Let's apply this texture to the flat grid. To do that, we need to go inside the initialize and load the texture into memory. We'll go down here and we'll copy the following code. After we load the color test.tga file, we're going to go and create a new pointer to a node texture, and this time we're going to load resources, textures, clovers.tga. This file is also located in the resource texture folder. Let's build that. For this to work properly, we need to make sure we go back down here and this time select to use texture number 2. So let's save this, build it, and give it a run. Okay, now we see our clover texture on the bottom mapped over top of our flat grid. And we have our test textures mapped on top of our triangle. Last thing we need to do is texture our houses. Texturing the houses is a little bit more involved because the shape of the house is not completely flat like the flat grid or the triangle. So we need to use texture wrapping over top of the house to fully texture the entire house. Our texture map is going to be square. So I'm going to represent it here by this square. Our house itself has a couple sections to it. We have the front side of the house, we have the right side of the house, the left side, and the back side. We also have the right side of the roof and the left side of the roof. I've divided the square up into the following dimensions. 40% of the image is from the left edge to the portion where it transitions from the front to the side. The rest of it is 60% here. Half of the image in the vertical direction represents the one side of the house, the other half represents the other side of the house. The peak of the house is going to be 20% wide and 20% tall. Knowing all these dimensions, I can then figure out exactly where all the important texture coordinates are on this image. I've labeled them here in this image. To texture the house entirely, we need 15 texture coordinates, 0 located at the bottom and 14 located at the top right. Notice the order in which I've numbered all of the texture coordinates. They're numbered from left to right and from bottom to top. It's important to know the numbering of all these texture coordinates so that when we look at the code inside the house class, you'll understand which texture coordinate I'm using with which vertex. The two triangles defined by 3, 6, 9 and 4, 10, 6 are not going to be used when we texture the house. These essentially are blank spaces inside the texture map which don't have anywhere to be mapped on top of the house. You want to make sure that when you wrap a texture on top of an object, you use as much of the texture image as possible. This will give you the best images possible on all your objects. You might want to print this image out when referring to the code, which I'll show you in a second. Now here's the actual image that I created that's going to get textured on top of our house objects. Here's the front side of the house. We have a large window. The right side of the house has a little window down here and some bricks exposed. We have the roof, and then we have the other side of the house. Notice that this black portion here are those two empty triangles which are not going to be used when we texture the house in the scene. Now let's go take a look at the code to apply this texture to our house object. First thing we need to do is open up our house.h and add to it our vertex2.h class. Inside the member variables, we need to add 15 members for our texture coordinates. So we're just going to call them m_t, and there's going to be 15 of them. Inside the constructor, we need to go and initialize each of these texture coordinates. Before I forget, let's modify a render function. Inside the house.cpp, let's go modify the constructor. If you refer back to the image that I showed you with all the texture coordinates, you'll see where I get all these numbers from. Texture coordinate 0 is the one located at the bottom left, so it's equal to 0, 0. 1 was the next one over, and it was 40% over from the left-hand side. 2 was all the way over on the right-hand side, so that's equal to 1, 0. You can go through here and double check to make sure all of these are correct. Now we can go and modify the render function. When we render, we make a decision whether we want to use textures or not. If we do, then we need to include our texture coordinates for each vertex coordinate that we're going to be rendering. So that's shown here. Again, you can refer back to the previous diagram to see if I'm using the correct texture coordinates with the appropriate vertex coordinates. If you don't want to use texture coordinates, then we render the object exactly the same way we did before. And that's all we need to change. Now let's go and apply texture to the house objects. First thing we need to do is go and load the textures into memory. So we'll do that in the constructor. So I'll replace this clover.tga with house.tga. And then inside the update, we need to specify which texture to use with each of the houses. I'll just specify to use the same texture for each house object. We can now remove this extra set texture ID since we no longer need it. Now the other thing we need to go and change is we need to make sure that our house object is rendered completely in white, or else we're going to have that same problem we saw before with the colors being a little bit off. We can go and delete this. We won't be needing this anymore. And we're going to set the roof color to be white. And the house color to also be white. We can delete all the code here that changes the colors of the houses, since we won't be changing them anymore. Now let's take a look at our scene. There's our 3 houses fully textured. If you create other textures for your houses, you can load them in as well inside the initialization function. Whenever loading a new texture, just copy the following code and replace the bottom line here with the texture you wish to load. In the update, just change the ID number to the new texture that you've loaded, or use the select texture function call instead, whichever you find easier to use. Oh, I missed a bracket here. Notice now we have 2 houses textured one way and a 3rd house textured a different way. So that's all there is to textures inside the game engine. Now, you may be wondering, why is it so much work to texture an object? Well, to tell you the truth, no one really textures object the way that I'm showing you. You don't want to be going around generating all the texture coordinates by hand. This is a lot of work, especially if your objects are complex, like a character for instance, or a human face. Instead, what you want to do is use a graphics rendering package which will automatically generate the texture coordinates for you. Then it's just a matter of loading in all the data from a file and applying it inside your game engine. We'll be doing that in a future VMK, but for now I wanted to show you how textures work inside OpenGL. Have fun texturing your world!